Hello everyone, welcome to KS Math Academy. In this video, you will learn the problems from exercise 2.1, chapter name Inverse Trigonometric Function for class 12 CBSE. First question, find the principal value of the following sine inverse of minus 1 by 2. So you can take y is equal to sine inverse of minus 1 by 2. So sine y is equal to minus 1 by 2. So you can consider like this. So this is nothing but minus of sine of 1 by 2 is 5 by 6. And we know sine of minus theta is equal to sine of minus sine theta. So sine of minus 5 by 6. And principal branch value for sine inverse is minus 5 by 2 to plus 5 by 2. So this value falls within this range. So principal value of this problem, sine inverse of minus 1 by 2 is minus 5 by 6. Second problem is cos inverse of root 3 by 2. So y is equal to cos inverse of root 3 divided by 2. So cos y is equal to root 3 divided by 2. So this can be written as cos y is equal to root 3 divided by 2 in terms of cos is cos of pi by 6. And principal branch value for cos inverse is 0 to pi. So principal value, this pi by 6 falls within that range. So principal value of cos inverse of root 3 by 2 is pi by 6. And for third question, cosecant inverse of 2. So y is equal to cosecant inverse of 2. So now cosecant y is equal to 2. And for 2 in terms of cosecant is cosecant pi by 6. And for the principal branch value here is minus pi by 2 to plus pi by 2 except 0 value. So this falls within that range. So principal value of cosecant inverse of 2 is pi by 6. Coming to the fourth question, tan inverse of minus root 3. So now can take your data as your y. So tan y is equal to minus of root 3. You can consider like this. And this value root 3 is tan of pi by 3. And tan of minus theta is equal to minus tan theta. So this can be written as tan of minus pi by 3. And our principal branch value for tan inverse is minus pi by 2 to plus pi by 2. So principal value of tan inverse of minus root 3 is minus pi by 3. It falls within the range. And coming to the fifth question, cos inverse of minus 1 by 2. So cos y is equal to minus 1 by 2. You can consider like this. So this is nothing but cos of pi by 3. And cos of minus theta is equal to cos theta. And here you know this formula, cos of 180 minus theta is equal to minus cos theta. Since falls in the second quadrant, minus cos theta. So here minus of cos pi by 3. So cos of 180 is pi by minus pi by 3, which is equal to cos of 2 pi by 3. And our principal branch value is 0 to pi. And this value here, it is 2 pi by 3. So it falls within this range. So principal value of cos inverse of minus 1 by 2 is 2 pi by 3. Next question, tan inverse of minus 1. So tan y is equal to minus 1. So this can be, the 1 is nothing but tan 45, so pi by 4. So tan of minus theta is equal to minus tan theta. So this can be written as tan of minus pi by 4. And our principal branch value for tan inverse is minus pi by 2 to plus pi by 2. Since it falls within this range, so principal value of tan inverse of minus 1 is minus pi by 4. Coming to the seventh question, this is secant inverse of 2 by root 3. So secant y is equal to 2 by root 3. And here this 2 by root 3 in terms of secant is pi by 6. And principal branch value is 0 to pi except pi by 2. So this falls within this range. So principal value of secant inverse of 2 by root 3 is pi by 6. And question number 8 is cot inverse of root 3. So cot y is equal to root 3, and this root 3 in terms of cot is pi by 6, and principal branch value for cot inverse is 0 to pi. This pi by 6 falls within this range. So principal value of cot inverse of root 3 is pi by 6. And for question number 9, cos inverse of minus 1 by root 2. So cos y is equal to minus of 1 by root 2. So in terms of cos is cos of pi by 4. So minus cos of pi by 4. And we know cos of pi minus theta is equal to minus cos theta. So this is cos of pi minus pi by 4. Take LCM. So this will be cos of 3 pi by 4. And principal branch value for cos inverse is 0 to pi. So principal value of cos inverse of minus 1 by root 2 is 3 pi by 4, since it falls within this range. And coming to question number 10, cosecant inverse of minus root 2. So cosecant of y is equal to minus root 2, and minus you can take outside. This root 2 in terms of cosecant is cosecant of pi by 4, and here this value cosecant of minus theta is equal to minus cosecant theta. So you can take your value here as cosecant of minus pi by 4, and here the principal branch value of cosecant inverse is minus pi by 2 to plus pi by 2 except 0. So this minus pi by 4 falls within this range. So principal value of cosecant inverse of minus root 2 is minus pi by 4. And coming to the 11th question, it is a combination tan inverse of 1 plus cos inverse of minus 1 by 2 plus sin inverse of minus 1 by 2. So you can consider first term as x, and here it is y, and for third term as your z. So x is equal to tan inverse of 1. So tan x is equal to 1, that is tan x is equal to tan 45, that is pi by 4. The range of tan inverse is minus pi by 2 to plus pi by 2. So tan inverse of 1 is nothing but our principal value now here is pi by 4. And similarly for calculation of y, here you can consider y is equal to cos inverse of minus 1 by 2. So cos y is equal to minus 1 by 2. So cos y is equal to minus of, this is cos pi by 3, and cos of pi minus pi by 3 is minus cos pi by 3. So cos of pi minus pi by 3, which is equal to cos of 2 pi by 3. And here the principal branch value for cos inverse is 0 to pi. So cos inverse of minus 1 by 2, the principal value now here is 2 pi by 3. And similarly consider your third data, z is equal to sin inverse of minus 1 by 2. So z is equal to sin inverse of minus 1 by 2. So sin z is equal to minus 1 by 2, and minus of, this is sin pi by 6. And we know sin of minus theta is equal to minus sin theta. So this is sin of minus pi by 6. So the principal, this value falls within the principal branch value. So sin inverse of minus 1 by 2 value is minus pi by 6. Now look at your question, x plus y plus z. So all the terms, principal values should be added. So here it is pi by 4, here it is 2 pi by 3, here it is minus pi by 6. So pi by 4 plus 2 pi by 3 and plus of minus, so minus pi by 6. So take LCM. So now it is 3 pi plus 8 pi minus 2 pi. So that is equal to 3 pi by 4 is our final answer. Coming to the 12th question, the same process for like your previous sum. So cos inverse of 1 by 2 can be taken as x and sin inverse of 1 by 2 can be taken as y, and so x plus 2 times y we have to consider. So x is equal to cos inverse of 1 by 2. So cos x is equal to the 1 by 2 here in terms of cos is pi by 3. Since it falls within the branch value, so cos inverse of 1 by 2 will be equal to pi by 3. And similarly, here y is equal to sine inverse of 1 by 2. So sine y is equal to 1 by 2. So 1 by 2 in terms of sine is sine of pi by 6. Since it falls within the range, so sine inverse of 1 by 2 value is pi by 6 now. And now substitute your values, principal values in the given equation. So for the first term, the principal value is pi by 3 plus 2 times second data is pi by 6. So you can cancel your items. So pi by 3 plus pi by 3, which is equal to 2 pi by 3. So this is our final answer. Coming to the third question, if sine inverse of x is equal to y. So here y is range of the principal value of sine inverse of x. So then you have to choose your value. So you have to consider like this. So y is range of principal values of sine inverse of x. That is nothing but we know very well minus pi by 2 to plus pi by 2. So here y value lies between minus pi by 2 to plus pi by 2. It's a closed interval, so lesser than and equal to, lesser than and equal to. So here option B is our answer. And coming to the last question in exercise 2.1, tan inverse of root 3 minus secant inverse of minus 2 is equal to. So the same way we have to do, consider this as your x and this as your y, and x minus y, the principal values you have to calculate and then subtract. And then you can choose your answer. So x is equal to tan inverse of root 3. So tan x is equal to root 3. So this is nothing but the pi by 3 value, and similarly here secant inverse of minus 2 can be taken as y. So secant y is equal to minus 2. So you can consider like this. So minus of the 2 will be secant of pi by 3, and this is nothing but secant of pi minus pi by 3, that will be minus secant theta. So here it is secant of 2 pi by 3, and since it falls within the range, so you can take your principal value as 2 pi by 3. So secant inverse of minus 2 will be equal to 2 pi by 3. So in this case, tan inverse of root 3 will be pi by 3. Now substitute your values here. So x minus y. So tan inverse of root 3 is pi by 3 minus tan inverse of minus 2 is 2 pi by 3. So take LCM. So pi minus 2 pi. So which is equal to minus pi by 3. So look at your option, B option. So option B is our answer. Meet you in the next video. Till then, it's bye from Dr. Kamachi.